Here I have 24th question of evaluating limit, and I will repeat again that this question is very important, very important, very conceptual, completely based on the fundamental concept of the limit, very similar to this question we had just solved here. All right, I hope you understand this question, and again I'm going to solve this question, but again let me tell you, I'm going from the very basic level, from the fundamental level, from the bottom level I'm going, so you will understand every concept about the limit. So please be a little more focused here. So let's begin from the fundamental, from the function itself. I'm going to find out I'm just going to plot the function into the graph. So I'm just trying to find out quickly the few coordinates. All right, x squared minus 1. So let's say this is x, this is y. All right, I'll just find out a couple of coordinates that you used to do in lines and angles and other coordinate geometry. So when I'm taking here 0, when x is 0, you'll get here minus 1. All right, when you're taking minus 1 square, that's 1 minus 1, that's 0. And again when you're taking plus 1, again plus 1 square is 1 minus 1, that's 0. And when you're taking 2 plus 2, 2 square, that is 4 minus 1, that's 3. All right, and when you're taking minus 2, you'll get minus 2 square, 4 minus 1, that's again 3. All right, and when you're taking 3 square, that is 9 minus 1, that's 7. So it is 3, then it is 7, so definitely another will be minus 7. Similarly, for quickly I'm doing for this second question, f of x equals to minus x square minus 1. All right, so when I'm taking x as a 0, it will be 0 square 0, so we'll get minus 1. And when I'm taking minus 1 square, that's again a plus 1, but I have here minus at the front, so minus 2 it will be. And when I'm taking plus 1, again I will get minus 2. And when I'm taking 2 square, that is 4, so minus 4 minus 1, that's minus 5. And when I'm taking minus 2 again 4 minus 5, I'll get, now I'm taking, let's say 3 square, that's 9, it's gonna be 10. All right, that's enough. So let's draw this, let's plot this all points into the graph. So here I have a very rough diagram, and I'm going to draw first this f of x equals to x squared minus 1. When 0, it is minus 1. All right, so when we are at 0, it's minus 1. Okay, and when we are at minus 1, it's 0. Okay, and when it's plus 1, we are at 0. When we are at 2, we are at 3. 1 2 3, so it's going to be here. All right, and when we are at minus 2, we are again at plus 3, so we are here. And when we are at 3, we are at 7, so 7 is here, almost here. All right, so let me connect this. So the function is going something like this. All right, so this is f of x equals to x square minus 1. And now let's draw this f of x equals to x square minus 1. When 0, it's minus 1. When we are at 0, we are at minus 1. All right, it's going to touch this one. And when we are at minus 1, it's gonna be minus 2, so it's here. And when we are at plus 1, we are at minus 2, so it's going to be here again. And when we are at plus 1, we are at minus 2, again it's here. All right, when we are at 2, we are at minus 5. 2 is resulting us minus 5. 1 2 3 4 5, almost here. All right, and when we are minus 2, we are at minus 5, so it's somewhere. And when we are at 3, we are at minus 10, so it's very at the bottom, let's say here somewhere. So let's draw this. So this function is something like this, f of x equals to minus x square minus 1. All right, now let's go to the question. Question is saying us find out the limiting value when x approaches to 1. So when x approaches to 1, where is 1? Let's first find out. Here is 1. All right, here at this point x is equals to 1, so we have to find out the limiting value at this particular point. And let me tell you one more thing, limit x tends to 1. What do you understand from this? This means x is not equals to 0, x may be slightly less than 0. all right, when x is slightly less than 0, so it will be towards this, or x may be slightly bigger than 0, so that time it will be here. So that's why question has given us two conditions. When x is less than or equals to 1, we need to choose x square minus 1. So whenever x is less than or equals to 1, including this one, right, including this one, we have to choose this function x square minus 1 for all those which is x is equals to 1 and x is less than 1. And second condition is when x is greater than 1, then our functional value will be minus x square minus 1. all right. So when it is x is greater than 1, so we are not going to take x equals to 1. So whenever it is greater than 1, we have to go through this, all right, whenever x is greater than 1. So we have two values of the function. When x is less than or equals to 1, we will go through this one, and when x is greater than 1, we'll go through this. So as I told you, x is going to approach 1 here. It means it may be less than 1. So when it is less than 1, we have to approach from the left hand side, all right. And while approaching from left hand side, we need to find out left hand limit, all right. So let's first find out the left hand limit. Limit x is approaching to 1 minus f of x, and when x is less than 1 or equals to 1, the question is saying us we need to choose this function, which is x square minus 1, all right, this value. So it's going to be now limit x tends to 1 minus x square minus 1. Let's plug the value. We'll get 1 square minus 1, that's going to be 0. So our left hand limit here, when we approach from the left hand side, the function value is getting here 0. And my dear friend, x may be slightly bigger than 1. So in that case, x will be something towards like this, all right. So slightly bigger than 1. So that time we need to approach from this function. We need to approach from this function, as the question is saying x is when greater than 1, all right. So let's find out that time right hand limit. We have to approach from the right, right. So let's find out right hand limit. Limit when x tends to 1 plus f of x, and the best suitable function this time will be this one, all right. So limit x tends to 1 plus x square minus 1. We have here minus, all right. So it's going to be now minus 1 square minus 1. So it's going to be minus 1 minus 1, that's minus 2. Oh my god, as I had told you in the previous video, that this time our limit is not going to exist, because the value of the function f of x is different when we approach from the left hand side to the same point x equals to 1, and when we approach from the right hand side to the same point x equals to 1, we have two different value, all right. F of x from the left hand side we have 0, and from the right hand side we have minus 2. It means both the value of the same function is not going to equal at x equals to, when x is going to approach 1, all right. So that's why we can say that limit is not existing, all right. Since left hand limit is not equals to right hand limit, limit does not exist, limit does not exist, all right. Always and always, as I told you, to exist a limit, you know, wherever you're going, any function you have, you know, if you're going to find out, let's say if you're going to find out the limiting value at this particular point, then you have to find out the approaching value from the left hand side, that we say left hand limit, and you need to find out right hand limit. We need to approach from the right hand side, that is called right hand limit. If you are finding the value of the function of a same point by approaching from left hand side and by approaching from right hand side, and if you are not getting the equal, then definitely the limit is not going to exist, because the value of the same function at the same point should be same, you know, always, whether you are going from this side or this side or this side or this side, wherever you go, all right, doesn't matter. Left hand limit and right hand limit should be equal, and if it's not equal, then it means limit is not going to exist. We cannot find out the limiting value at that particular point. I believe this video was helpful for you, and if there is any more confusion or doubt about this video, then please feel free to comment below this video, any point, anywhere, any confusion you have, then please feel free to comment below this video, and please don't forget to subscribe the channel and hit the like button of this video. Bye bye.